Good morning, friends. Moment area method for the finding slope and deflection. What is moment area method? This is one of the easiest method for finding deflection and slope of a beam with the help of area of bending moment of the beam which is loaded with some load or any moment at any point or on whole span. That means we are finding slope with the help of area of bending moment diagram, and we are finding deflection with the help of moment in bending moment diagram. Next, introduction. The idea of moment area theorem was developed by Otto Moore and later started formally by Charles E. Greene in 1873. It is just an alternative method for solving deflection problem. In this method, we will establish a procedure that utilizes the area of moment diagram, actually the M upon EI diagram, to evaluate the slope or deflection at selected point along the axis of a beam or frame. In this numerous engineering applications where deflection of beam must be determined, the loading is complex and cross-section area of the beam is vary. When the loading is complex and cross-section area of beam is vary, this method is used. Next, it is convenient to use this method with great advantage. So advantages of this method is: first, cantilever beam slope at the fixed end is 0. In cantilever beam, slope at fixed end is 0. In simply supported beam, symmetrical loading, slope at midspan is 0, and in fixed beam, at both ends, slope at each end is 0. So these 3 points should be taken care while calculating slope and deflection for different type of beam. Next, deflection of beam. Assumption for slope and deflection by moment area method. These are the assumption while we are calculating the example. This assumption we are taken. First, beam is initially straight. Now, if we are assuming the beam is initially straight, is elastically deformed by the load such that the slope and deflection of the elastic curve are very small. If we are given load in beam and slope and deflection from that deflection curve or elastic curve is very small, where our beam is elastically deformed. Next, deformation are caused by bending, where deformation or deflection shape is caused by bending. Next, theorem 1, moment area theorem 1. The change in slope between any 2 points on the elastic curve equal to the area of the M upon EI diagram between 2 points. That means here these are the beam where UDL is applied, A and B, these are the 2 points. If we draw the diagram of moment M upon EI diagram where EI is equal to constant, where we are drawing M upon EI diagram here. Diagram is like this. So A and between A and B, these are the diagram of M, and in the slope between any 2 points, these are the 2 points A and B. Elastic curve, these are the elastic, also said that elastic curve. If we are finding slope between A and B, so we have to calculate area between these 2 points. So we got slope. The equation of slope theta is equal to integration of A to B M upon EI dx. So it means we have to find area between these 2 points. It gives slope. Next, theorem 2. The vertical deviation of tangent at point A on the elastic curve with respect to the tangent extent from another B equal to the moment of the area under M upon EI diagram between these 2 points A and B. Here we have to for moment area theorem 2, seen figure like this. Here point A gives tangent A. Here deflection curve or elastic curve is here due to bending. At point B, the moment area theorem 2 is said that the displacement of point B, here point B gives displacement from the tangent A. So tangent A gives the deflection at point B here, TBA, it's called deflection due to A at B, equal to, this deflection is equal to moment of M upon EI diagram between A to B. So if we are finding a deflection at point B from A, it's finding from moment due to M upon EI diagram. So if we are finding deflection at B, so we have to find moment between A to B, so it gives the deflection at B. Okay, now these methods are require an accurate sketch of the deflection slope upon above two theorem. Theorem 1 is used to calculate change in slope between 2 points on elastic curve, and theorem 2 is used to compute the vertical distance called a tangential deviation between a point on the elastic curve and a line tangent to the elastic curve at a second point. That means theorem 1 is used to calculate slope and theorem 2 is calculate deflection. Theorem 1 is used to find slope using area, and theorem 2 is used to find deflection using moment between M upon EI diagram. The simple clarification of finding slope and deflection using moment area theorem is this. Next,